Hello students, if you remember in last part we have seen the self-induction and we have seen how it was derived. In that case we have seen when current flow from the same coil, it will induce a EMF and induce a current in the same coil with some magnetic flux or magnetic field is produced in exactly opposite direction. And this phenomenon of production of EMF, current and magnetic field in the same coil due to flow of some current to the same coil is said to be principle of self-induction. And self-induction was represented by L. It is said to be self-induction or coefficient of self-induction. In that case we have seen magnetic flux linked with the same coil is found to be directly proportional to current flowing to the same coil. If current flowing to the same coil get increased, this current get increased, then magnetic flux link will get increased. Definitely it is same, but only difference is what? The direction of resultant current and induced current and EMF is exactly opposite according to Lenz's law. So this part we have learned. Phi is directly proportional to I. Suppose I want to remove the proportionality sign, what we can write? Phi equal to some constant L into I, where L is said to be coefficient of self-induction or it is said to be self-induction. From this you can find the value of L equal to what? Magnetic flux per unit current. So this is the first phenomenon. This is the first formula, not a phenomenon, that we have derived from this simple equation. L equal to magnetic flux per unit current flowing to the same coil, that is called as the self-induction. The same thing they have taken in your book. Magnetic flux produced per unit current, it is said to magnetic flux produced per unit current flowing to the same coil is called as a self-induction. This is one of the definition that we have taken. Let's go to second definition as according to the book we are going. As we have derived according to Faraday's law, we can write E equal to minus d phi by dt, and if you put the value of d phi as this one, just we put the value of d phi as this one, then what we can write this as minus, I will write here minus d dt of phi means what? L into I. Just phi is equal to L into I. L is constant, take it outside, minus L into di by dt, and that is nothing but E equal to this formula we get. From this formula how we have derived? We have derived from Faraday's law. Faraday's and Lenz's law we can see. From this find the value of L. So this formula implies that L equal to E divided by di by dt with a minus sign. L equal to E divided by di by dt with this minus sign. So here this is the formula that for L self-induction we have derived secondly, and this is nothing but another definition of self-induction. Self-induction is defined as a ratio of EMF induced in the same coil to rate of flow of current per unit time in the same coil. Their ratio is always constant, and that ratio is said to be self-induction. That is second definition they have given in your book. Now let's see the third definition. The third part, they have given the same definition in two ways that we have seen now. Now we have to see the same definition by third part. Third part means what? Third method we have to see. So how to see this third method? For that, as we know that whenever current increases in the circuit, and work will have to be done in order to establish the magnetic flux associated with the steady current I0 in the circuit. Now in that case, the work done in a time dt can be written as dw, and dw equal to the product of current EMF induced and current which will flow through the circuit into the time, that will give the work done in electrical circuit. E amount of EMF is induced, I amount of current is flowing for time dt, and that's why this is nothing but a work done. Now I want to find out the total work done, then we have to integrate this equation. So before going into total work done, just we'll solve this part first. E into I into dt. Now what is the value of E according to Faraday's law? We know that we can write this dw equal to E means what? Minus L into di by dt, that is the value of E according to Faraday's law, into I into dt, as it is this part, remaining part I have written. Now if you see, this dt is cancelled with this dt. What is remaining? L into minus L into I into di. minus L into I into di. That is a little bit work done required to do the work on the opposite EMF produced. This much work done is required. This is small work done we have calculated for small current di. Work done is dW. Now I want to find out total work done. Integrate this equation. Both sides of this equation should be integrated. And here current changes from 0 to maximum value. Current changes from 0 to maximum value I0. So limit of integration to right hand sides are 0 to I0. Integration of dW is of W, that is the total work done. W, total work done. Then what is minus L is a constant, take it outside. Integration of 0 to I0 of I into di. What is the integration of I? It is I square divided by 2. So minus L into I square divided by 2. Limit varies from 0 to I0. While doing this upper limit minus lower limit, if we do, what we get? We get here minus L I0 square divided by 2, or it is set to minus 1 by 2 I0 square. So that is the work done. Just we have find out minus L I0 square by 2 or 1 by 2 minus 1 by 2 L I0 square. This is a basic work done we have find out. If you want to take a magnitude only, just take this plus sign. For a magnitude, minus become plus, or we have to neglect the minus sign. So this is nothing but a work done we have find out. In this equation, if this I0, we have taken I0, just I will write here, if I0 equal to 1, if I0